So lab 6, this is very similar in terms of what you're going to be doing as the last lab, I believe. Actually, no, last lab was numeric conversion, so that's actually different. I think this was like an old lab that we used to have that I think it was like tic-tac-toe. But yeah, this is like just working with command line, making outputs that look like something, which is a little bit confusing. I don't know if you guys have ever seen like chess being played on a terminal, but this is kind of what we want to be doing. We're going to implement a Connect 4 game that actually shows up with a bunch of print statements when you play, and you'll use numbers like one to choose an option of where to go, for example. So there won't be any mouse clicks or anything. It's all keyboard based. So this lab's basically designed to introduce you to lists, how to use nested lists or what we call 2D lists or multiple dimensional lists. And you're going to loop through these lists, change them depending on, if you add an X or an O somewhere on your Connect 4 game. And you shouldn't have any issues where it's like, oh, if someone wants to put a token outside of these lines, or if you imagine the Connect 4 game, which is like, let's see, you can just see here, where you've got these little grids and you put these little circles inside. You want to make sure that you can't just put something on the outside of it. And I feel like obviously that's inherently understandable when you're looking at the game like this, but when you have lists like this, it's very easy to try and, you know, access an index. Let's say that this whole game is made with one list. You've got one list and there's how many? There's four different little arrays inside of that list. Or so there's four lists within a list. Therefore, you've got a two-dimensional list. Let's say that you try and access, we've got four, so 0, 1, 2, 3. Let's say that you try and access the fourth index in this two-dimensional list. Well, it would be, that would mean that there'd be another row under all of these, and it won't work. And so we want to make sure that we don't have any issues with, indexing out of bounds. But, of course, we need to make sure that we are robust with how we do that, because the players are allowed to select how big the board is. Since there's no physical constraints, we're allowed to choose any size of the board. So you're going to take in an input for the height and length of the board. In this case, we've got 4 rows because we selected 4, and then 5 columns because we selected the length of the board being 5. And the way that you would probably instantiate this list is, if you think about what you're doing, you're making a two-dimensional list. You'll have to, if they put 4 as their input for the height, then you'd need to make 4 lists within your overall big list. And then of course, tell the players what their tokens are, and then you're going to have to do some logic, which goes through and says, well, if they want to put in, looking at the game again, you can only put in tokens from the very top. There's, nothing going in sideways. And you remember from gravity just goes all the way down. So, imagine that they say, oh, I want to put it in 0. That's how we determine that it goes down here. So in this example, they said, which column would you like to choose? And the player gets to choose from 0, 1, 2, 3, or 4. And you need to implement the logic that says, well, when it's 0, find column 0, and then keep looking. How do I know when to stop? Actually, let me see if I can log into my old thing and just move this away. Move this down so you can actually see it. You need to look, because you're looking in columns, you need to look, check. Is this a dash? Well, if it's a dash, then I'm going to keep checking because I don't want to place it here yet. I want to go as far down as possible before or until I find a value like this. So let's say that this X is here and you try to add something else. You want to keep looking, and you're here now, and then you look towards the next one. And if there's something already there, that's how you know where to place your object, right? And so, as we go through the example, the second player places something, they use a different token or letter. And these are just characters. So maybe you'll have an array of characters, and you can just modify them. Like these little dashes are characters themselves. So you can use, a checker that checks like, well, if there's, what's it called? If there are dashes here, then you know that those are empty spaces, because again, empty spaces are just going to be output like this. So you might want to just use an array that has a bunch of dashes in it. And then as you can see here, once you have an entire column filled by the same letter or token, then you're going to say that they win, and then you need to stop the game. Or I guess if there's no win yet, but there's no spaces left, then you need to end the game and say that nobody wins. And so there's a few things that you need to be checking. You need to be checking, is this, I guess you could check every single column and see, is every column filled, or I guess since it's connect four, it should just be, four different, four tokens in a row. So you're probably just going to want to look and see and make a checker that checks for every single column, which, might feel like a lot, but if you loop through, it doesn't take too long. There aren't like 1,000 columns, 1,000 rows, so it's not going to be too bad. But there will, it will take some thought into figuring out the logic behind your code to check these things. And I know that I think the last project in this class, I don't know if it's changed or not, but it's like a Sudoku game that you're going to implement. And that project really does, use this type of implementation in a game, because Sudoku has like little grids and there's numbers, and you need to check like, well, are all the numbers in this list, for example, do they all, do you use like 1, 2, 3, 4, 5, 6, 7, 8, 9? Do you use all of those numbers? And so you have to be constantly checking things. Every single time you put something new, you need to check, has the game been won yet? And that might seem tedious, but if you use for loops to loop through the entire array or entire board, in a sense, then you can use that as your method. I don't know if this game requires diagonal, but let's see. Let's just keep looking and see if there's any more explanation. So it says that you can access these elements through this method. So, just having a board that's a 2D array, and then you access using your, what's it called? The first index here, or the first thing here, represents, each mini list within the list. Because again, if you remember, a 2D list starts like this. You have a list like that, and then you have stuff inside, but you have lists inside. So it'd be like that, that. And so this whole list here represents the whole grid. And then each list here would represent each row. And that's how you'll start accessing things. So again, make sure that you implement your grid or game board like this, and you can instantiate this depending on whatever they input here. So you can insert things using this. You can access row, column, and use that to place things in. So again, as I said, if they put in their column input here, you're going to want to access that specific column, but then you'll have to figure out which row it goes in. Is there something in here already? Well, then if there is, then I need to put it right above, right? So let's see. So when printing the board, you should print the board upside down by printing from the last row. So if we've got, let's see, if we've got the rows like this, well, this is the first row, then we need to print it upside down, I guess, basically like how the actual game works, like gravity. This is row 0, row 1, row 2, etc. But I think it makes a lot of sense, when you have a 2D list, that, oh, the top row is going to be row 0. That's just how we read it, right? I mean, if you look at this, it makes a lot of intuitive sense. And so I think it doesn't really matter because in the end, all you need to look for is 4 in a row, right? So it doesn't matter if it's upside down or sideways, whatever, that's what you need to be looking for. But in terms of printing it out, you want to make sure that it is in this format. So I guess you'd need to print out, row 0 last. So start from index 3, and when you're printing each row within that 2D list that I showed you, just start from the top index and go down until you're at the end. So things that you need to consider is that the board will be 4x4 or greater, and the auto grader will always choose something that's valid. Well, the input for the column, if we've got how many rows? 0, 1, or column 0, 1, 2, 3, 4. They can't, the auto grader will not just put in a 5. So you don't need to check that. It says the column that the user chooses to place their token into has space. I guess, yeah, so if you've got one that's like full, like this column, I mean, I know the game's 1 here, but I guess if it's full, you can't place anything else. You need to make sure that the row's not full or the column's not full. And how would you do that? Again, you can use a similar method to how you will implement your checker. If you know the height and you look at every single column, you can ensure that, well, if the height here is 4, then you need to look at all 4 and see, is there a value that's not dashed? So you could say like, oh, here's all of the elements in this column. Is there a dash anywhere? If there's a dash somewhere, that means it's not it. That it's not full. So that's something that you could do. Yeah, so they can win vertically or horizontally, but not diagonally. So this makes it a lot easier for you. You don't need to check, like, is this, and this true? Are these all X's? Instead, you just need to check horizontally, which is pretty easy in my opinion, because again, through the implementation of the 2D list, this is already like easily accessible because this would just be index 0, 1, 2, 3. So you would just check the 4 consecutive things, and you could do that for every single one. You would need to make sure you can't just say like, oh, I'll check this one and I'll look at the next 3 addresses. I'll move to the next one, look at the next 3 addresses, because once you get to the 3rd one, you can't access something out of range. So, you'll do some math to think, when do I stop doing this? Because once I've checked this and once I've checked this, I've already checked all the possibilities. If there is no win, then there's not a win, because this is 4 and this is 4. And if those are the only 2 options that you've got. So you can only, you might, try and look at a few different sizes of boards and see, is there a pattern between this? Well, this one, there's 5 columns, and I only have to check these first 2. So I check 1 plus 3, 2 plus 3, and then I'm done. I don't know, maybe if it was 6, it would be 3. And so if you do that, then you can check and see. But I'd say play around with it, or maybe even draw it out just so that you can think about that in your own head. So some certain things that we're going to want you to implement, there's going to be the function print board. So the board variable here is going to be a variable that is actually the 2D list. So since your game is implemented with a 2D list, it's not, when you print out a 2D list, it'll show all those brackets, it'll show everything, but that's not what we want. We want to show the board in this format. And if the board, for example, I'll just write out what this board would look like. Well, row 0 is the one at the very bottom, right? Because we print upside down. So it would look like this. So that'd be, well, actually, that'd be our first row. And then we'd have our next rows, 1, 2, 3, 4, 5, etc., right? Because they're all the same, moving forward. So this is what our board variable would look like. But, you have to do something to print it out to make it look like that, right? So that's what this specific function here is going to do. All right. The initialize board, well, this is going to, make that 2D array. So this is actually going to make this board variable. And let's see. Yeah, so it says this will take in the number of rows and number of columns from the user input. So again, from those first two lines of user input, and then it will make the 2D list. So the one I just showed, right? And depending on how big you make it, then you fill in a dash for every single one, you return it, and that becomes your board variable. So you might have something that looks like board equals initialize board, and then I don't know, 5, 4. Of course, those are going to be the inputs, right? So num rows, num calls, and that's that's what you're going to use it for. However, of course, you need to implement this by yourself. So that's what this function will do. We've got a couple more. It's not too much, actually. This one's pretty small. So insert chip, it's going to take in the whole board. So that variable, or the 2D list variable that I was just talking about, you'll take in the column number. So, when you access something, let's say it's I, J, you can think about this as row, column. So you would access, this column variable is the same here. But then, when you insert something, you need to figure out which row are you going to. And again, I told you the way that you figure out the row is you have to look at the next row in the same column. If there is an empty space, then keep, going down the board. And if you reach something that's already there, like an X or an O, then you need to place it in the spot right above it. So you'll need to calculate this row value. And then you can just say, oh, at that specific spot, I'm going to put in my token, right? So that's what you're going to do in this function. And again, here it says, we'll find the next available spot in that column if the token's already there. So yeah, and so the index of that row, the index of the row that the token is placed in is returned. So you're going to return actually this row value here. So you can actually see where it was placed. I'm not exactly sure why you'd need to do that unless there's some extra implementation, and we'll see. I think it's in the next function. Yeah, so check if winner. So again, I was saying that you need to do each time check is every time you place a new token, you need to check is the game won yet. So I guess the way that I was talking about it before is I was saying you could go through the entire board every single time and just check every possibility, but I think that that's not really that efficient. So maybe writing a function like this, based on where you place the token, since we know that the game isn't, won yet. If you place a new token and it causes the game to win, well, all you need to do is check, 4 possibilities. Let's say that in this game here, you put in a token X right here. You would just have to check, you just have to check like which column you place it in and what row, because you can't have diagonal wins, right? So if there were a bunch of X's here already and it caused you to win, you'd only have to check this row or this column if there were X's in the other direction. So I think that's what we're trying to do here. So this function will take in the column in a row that we're going to check. And of course, which token are we looking for? And I guess if you do those checks properly, like I was saying, you'll just return true or false. And this way you have a very easy method to check if the game is over. And then you can do this part where it's like, oh, player 1 won the game. And if this never happens, but the board is full, so maybe one of your first checks will be like, oh, is every single thing in the board full? Then you'll have a tie. So this check if winner. Well, so maybe if you're looping this game until the game is over, you could say like, wow, I don't know, just keep checking. Is there a dash inside the board at all? If every single dash is gone, and the game is still not won, so if check if winner is still always false, then that it's a tie. You don't really need to do any extra implementation for that. So if you do it in this method, you'll probably do the best by just I know it says implement the methods in this order, but I think it might be easier to start with the initialized board because I think you really need this to print out the board. So I might like move this because I think that that's probably more important. But since I kind of showed you what I wanted from how to initialize the board, that's what you're going to try and do. It's not too complex, but I will say that the hard part is probably checking if there's a winner. But if you know, purposefully and tactfully use these column and row variables to check because there's no diagonal wins to check, then it should probably be not too hard. And there's some more sample outputs here. Yeah, let's see. So every single time you see there's going to be a check to see have they won, and only when they win. And of course, you are checking every single time. In this case, player one, I think, let's see. I don't know which side is put. Okay, player one is the X, right? So player one keeps placing these X's in column 0. So they just place this here. And what this will do is it's going to check, every possible spot in these in the column and in this row and see that there's no win and it will stay as false. So that's probably how you're going to want to go about it. You're not going to want to check every single column and row because it doesn't make much sense, since it would take a lot of time. And also, I think it's just more tedious, right? So does anyone have any questions about this? If not, then I will be here, but um, I'm not really going to go too much into detail about the checking because I already kind of explained the method, but I'll be here to answer any questions you might have. So just let me know if there's anything that you don't understand.